Now, the basic assumptions of linear programming. One, condition of certainty. When you talk about condition of certainty, you must be certain. The problem must be certain that you must get the solution. Linearity, we are talking about the problem must be equated in terms of relationship. There must be a relationship between independent problem and dependent problem. The output must give the input. No, the input must give an output. Divisibility, the solution should have a whole numbered list. Additivity, you must have a summation. All the resources that you're making use of must give us a summation of your problem. Fitness or finiteness, your constraints and your objectives must be in numbers. Optimality, the solution that you're getting must be the best. And the solution can either be minimal or maximum. You're minimizing your cost or you're maximizing your profits. Next is, how do you formulate a linear programming? Now, in the formulation of linear programming, there are things that we need to put in place. The ingredients of linear programming. Number one, determine the variables in the problem. Number two, for example, let X represent the units produced. That is how you determine the variables in a problem. Number two, determine the objective function of the problem. Now, in objective function of the problem, it's either maximization or minimization. Now, in maximization, the equation will be Z equals to AX1 plus BX2 plus CXN, whereby Z means maximization variable. A, B, C, N are the constant variables. X1, X2, Xn are the decision variables. Determination of constraint function. How do you come up with constraint? Constraints are actually limitations. The limitations can be structured in the form of x1 plus x2, x2 plus xn, xn, an, xn is less or equals to b, meaning that we are introducing inequalities, whereby x1, x2, and xn is greater or equals to 0. Determine the optimal solution. Getting the best outcome from the problem, which can either be minimization cost or maximization of profit. So these are the ways we can model our linear programming problem. Now, methods of linear programming. There are two methods of linear programming. One, we have graphical method. Two, we have simplex method. Problem. This is the problem that we have. So we are solving a problem. A fruit company manufactures two types of fruits, which are basic type A and the super type B. Each fruit of type B takes twice as long to produce as one type A, and the company will have time to make a maximum of 2,000 per day if it produces only the basic type. The supply of the raw material is sufficient to produce 1,500 fruits per day, both A and B combined. The super type requires a fancy packaging of which there are 600 per day available. If the company makes a profit of $3 and $5 per fruit, respectively, on fruit A and B, how many of each should be produced per day in order to maximize the profit? Now, that is the nature of a question that we expect to get as far as linear programming is concerned. So the question that we are asking ourselves, how to get the solution? When we are getting the solution, there are two ways. Either we are solving it in graphical method or we are solving in simplex method. So this question, we start with graphical method. In graphical method, number one, what to keep in our mind: determine the variable of the problem. 2, determine the objectives of the function. 3, determine the constraint functions. Then 4, find the optimal solution using graphical method. Now, we are in the problem. Determine the variables. How do we determine the variables? Let x1 be the fruits of the basic type A produced per day. Let x2 be the fruits of super type B produced per day. Number 2, determine the objective function. Maximization of profit. So in this question, we are maximizing the profit. So the equation will be z equals to 3x1 plus 5x2. The constraint. Determine the constraint function. How do you come up with the constraint function? x1 plus 2x2 is less or equals to 2000. x1 plus x2 is less or equals to 1500. x1 is less, x2 is less than 600. But x1 must be greater or equals to 0. So that is our constraint function. So converting the inequality into equality in constraint function. So we need to do what we call conversion. We convert the constraint into, we convert the inequality into equality. How can we do that? Very simple. We say x1 plus 2x2 is equals to 2000. It was less than, but now equals to. x1 plus x2 equals to 1500. It was less than 1500, now it is equals to 5000. 1500. x2 is